Hey guys, this is Mrs. Bennett again. We are going to be talking about half-life now. Half-life is the time it takes for half of a sample to decay. How is it going to decay? It's going to go through nuclear decay like we discussed in the first video. It has an unstable nucleus, and it's going to go through that radioactive decay by emitting different particles that could be dangerous to us at high levels. Here's an example of a graph where we have the amount of substance and the time in days, and you will notice it is a curve. This curve will never reach the x-axis, because you will always have some trace amounts of this substance. So for instance, if I'm looking at this particular substance, if I wanted to find the half-life, looking at this graph, I have 80 grams. Half of 80 is 40. So if I go across the graph to where it touches that line and go down, the half-life for this particular substance is 2 days. Some are days, some are years, some are many, many years, and some are just seconds. Now, in order to calculate the half-life, you will need to know this formula. You may want to add it to your formula sheet if you have started one. The total time over the half-life will give us the number of times we have to divide by 2 to figure out how much of a sample would be left if it went through that many half-lives. Let's just do some examples so I can show you how this works. All right, here's an example. Radioactive iodine 131 has a half-life of 8 days. The amount of a 200-gram sample left after 32 days would be, so that formula, N equals total time divided by the half-life. So the total time is 32 days. The half-life is 8 days, so 32 divided by 8 is 4. This tells me we're going to take our sample through 4 half-lives. So why 4 half-lives? In order to do the 4 half-lives, we're going to have to divide by 2 4 times, because it's the amount of time it takes the sample to decrease by half. So 100 divided by 2, 200 divided by 2 is 100. 100 divided by 2 is 50. 50 divided by 2 is 25. And 25 divided by 2 is 12.5 grams, and that answer would be B. So we divided by 2 4 times. Okay, another example. An isotope of cesium-137 has a half-life of 30 years. If you're starting with 1 milligram and it disintegrates over a period of a total of 90 years, how many milligrams would remain? So using that formula again, total time divided by the half-life. Total time is 90 years. Half-life is 30. 90 divided by 30 is 3. So we need to take this sample through 3 half-lives. Okay, so we're going to take that 1.0 milligrams, take it through 3 half-lives, so I've got to divide by 2 3 times. So 1 divided by 2 is 0.5. Divided by 2, so 0.5 divided by 2 is 0.25. 0.25 divided by 2 is 0.125. So how much of the sample are you going to have left? Is 0.125 milligrams. Okay, let's try another sample. You've got a 2.5 gram sample of strontium-90 was formed in 1960 in a 1960 explosion of atomic bomb at Johnson Island in the Pacific Test Site. The half-life So we've got half-life. It's 28 years. In what year will only 0.625 grams of this remain? So let's figure that out. You're starting with 2.5 grams. So we have to take it through half-lives until we get to this, because our total goal is filling in this information. And it wants to know in what year will only 0.625 grams remain. We've got the half-life of 28 years. We need to figure out N so we can figure out the total time that this sample went through decay, so then we can add on and figure out how many years. So if I take 2.5 and divide it by 2, I get 1.25. Still haven't gotten to that 0.625. Divide it by 2 again. 0.625. Now we are there, so it took us 2 half-lives to get there. Okay? So in solving for the total time, 2 times 28 is going to be 56 years that this thing went through radioactive decay. So how am I going to figure out the time? So we start off at 1960. If we add 50 years to 1960, that's going to get us to 2010. We add another 6 years, it gets us to 2016. Okay, another example. Actinium-226 has a half-life of 29 hours. We're starting with 100 gram and it disintegrates over 58 hours. And we want to know how much is going to remain. Total time divided by the half-life. So total time, 58 hours, divided by the half-life of 29 hours. 58 divided by 29 is going to be 2 half-lives. So if I'm starting off with 100, divide by 2 is 50. Divide by 2 is 25 milligrams. There's your 2 half-lives. Okay. The half-life of radium-224 is 3.66 days. What was the original mass? So we don't know what we're starting with if we have this that remains. So once again, we're still starting with our formula. Total time, 7.32. Half-life, 3.66. For 2 half-lives. Well, we don't know what we're starting with, but we know we are ending up with 0.0800 grams. So it has gone through 2 half-lives to get to that. So I have to work backwards. Instead of dividing by 2, I multiply by 2 to go backwards, to go in this direction. The other problems, we had to divide by 2 to get to the final amount. So to get to the original amount, we're going to do the opposite and multiply by 2. So if I take 0.08 times 2, that gets me to 0.16. 0.16 times 2 gets me to 0.32 grams. Okay. The rest of this PowerPoint just gives you some examples of some isotopes that you encounter throughout your life. Potassium is a natural occurring isotope. All isotopes are naturally occurring. Okay. For instance, eating 600 bananas. Bananas have a lot of potassium in them. Good for cramping of muscles. If you eat 600 bananas in a year, that's the same as 1 chest x-ray. A plane ride, 2 millirims of rays. 27 millirems per year is what you should not have any more than 27 millirems per year. Smoke detectors emit alpha particles. So you see those. You are exposed to those every day. Okay, that is all of nuclear chemistry that you will need to know.